Good morning everybody. So today we're going to be continuing doing some recapping of some different topics that we have covered this year. So we're going to go through the questions. I'll show you the questions, you'll answer the questions, I'll then go through the answers for you to be able to access. And if you haven't got any quite right, then you can see where you might have gone wrong and how I can show you how you actually would work that out. I'd like you to start off by first of all telling me the time on the analogue clock. Once you have told me that as an analogue, you can tell me as a digital, tell me what it would be if it was in the morning, and tell me what it would be if it was in the afternoon as well. Then for number one, what is the perimeter of the shape? Now remember, perimeter is the whole distance around the shape, so you'll need to add all the sides together. To compare, using less than, greater than and equal to. Now remembering we need to use our conversions to first of all make sure that they are all in either centimetres or metres before we can compare them. Now remembering, I'm going to show you the conversions now to just have a quick recap. So these are our conversions. So we know in 1 centimetre there are 10 millimetres, and we know in 1 metre there are 100 centimetres. Now remember, when we're converting, if I want to put centimetres into millimetres, I'm going to times by 10 because it is 10 times more. And if I'm going from millimetres to centimetres, I'm going to divide by 10. So when we're converting, that's how we obviously do that. When we've got metres and centimetres, to go from metres to centimetres, we're going to times by 100 because we can see that there's 2 zeros. And when we go from centimetres to metres, I'm losing my 2 zeros, so I'm going to divide by 100. So use that to help you when you do number 2 to convert. Then it says how many metres are equal to 1,000 centimetres. So again, think about your conversion rates. If you're going from centimetres to metres, what are you going to do? And then finally for number 4, what is 100 less than 923? So you might want to put this into a column method to show you're working out. Once you've done that, press play and we'll see if you got all your answers correct. So let's look at number 1 then, or even the clock. So the minute hand is obviously the longest hand. Now the minute hand isn't on the numbers, it is on the little lines. Now remember, the little lines are minutes. So it is just on the second one before it gets to the 6th. Now because it is before the 6th, we obviously know that this is going to be past, whereas this side is going to be 2. And I can count from my 12 and see how many minutes passed. I can count in 5s to start with, as I know between each number there are 5 minutes. 5, 10, 15, 20, 25. Then I want to count my minutes, 26, 27, 28. So we would say that it was 8:28 minutes past. If I look at my hour hand, it's gone past the 8, so it will be past 8. Now if we were to do this using a digital clock, remember the right hand side tells us how many minutes past, but we already know it's 28 minutes past, so that's a nice easy one to work out. And because it is past 8, if it is in the morning, we need 2 digits, so we need to put a 0 before the 8 to make it 8. And if it's in the afternoon or the evening, we add 12 to 8, which is 20. So those are your answers. Okay, so for number 1, we're going to be looking at the perimeter of the shape. So my perimeter has got 4 centimetres down one side. It has got 7 centimetres down another side and 6 centimetres on the last side of my triangle, and I'm going to add all of those together. I can see that 6 and 4 are my number bonds to 10, so I've got 10 plus my 7, so it's going to be 7 centimetres, and that will be your answer. Then if we have a look at number 2, we're going to compare 85 millimetres and 8 centimetres and 5 millimetres. Now because we're in different units of measure, I'm going to convert it so they're all in the same unit. Now I would probably say that because if we're going from centimetres to millimetres, we're going to times by 10, that would be easier. So if I have a look, I've got 8 centimetres. I know to get to millimetres I times by 10, so I'm going to do 8 times by 10 is 80 plus my 5 is 85 millimetres, which I can see you are going to have, it's going to be the same because I've got 85 millimetres on one side and 85 millimetres on the other side. Looking at number 3, it says how many meters. So I want to know how many meters are in 1,000 centimeters. So because I've got my centimeters and I want to make it to meters, I'm going to divide by 100. So because I'm dividing by 100, I can take off my 2 zeros. So my answer should be 10 meters, because I can just take off my 2 zeros to show that it will be 10 meters, because in 1 meter there are 100 centimeters, so in 10 meters is going to be 1,000 centimeters. Finally, we want to know what is 100 less than 923. Well, if it's 100 less, I need to look in my hundreds column. And in my hundreds column, I've got 9. If I want 100 less, it's going to become 800. My 10s are going to stay the same. My 1s are going to stay the same. So my answer is 823. Okay, this time I'd like you to again tell me the time on the analog clock. Tell me also it is a digital in the morning and the afternoon for really good practice. Then we're going to be moving on to some fraction work as well today. So number 5 is looking at what fraction is shaded. So remember, the numerator tells you how many parts are shaded. The denominator tells you how many parts there are in total. Then for number 6, you're working out the perimeter. Number 7, you need to complete the sentence. So something millimeters equals 7 centimeters. So thinking about our conversion rates again. And then finally, number 8, what is 28 divided by 4? Now you can use your circle method for this, or you can do your 4 times table if you also know that as well. As soon as you've had a go at doing that, press play and we'll have a look and see if you've got your answers correct. So let's have a look. My minute hand is pointing to my 11 because that's my longest hand, and we know that that's going to be on the 2 side of the clock. Now because it is on the 2 side of the clock, I want to know how many minutes to the hour it is going to be. So how many minutes from the 11 to get to the 12? Well, I know that there is 5 minutes between each number, so I know that it's going to be 5 minutes to, because if I work backwards, I know from 12 to get to the 11 it's going to be 5 minutes. And if I look at my hour hand, it is just before the 3, so it hasn't got to the 3 yet, so we would say it's 5 minutes to 3. Now again, if we were doing this as a digital clock, now remember, when we actually look at our minutes, that tells us how many minutes past it has gone. So it's not going to be 5, you're not going to put 5 in there because it's not 5 minutes past. So I want to know how many minutes past it has gone. Well, I know there are 60 minutes in a clock, so if I take off 5, which is how many minutes to, I would get the answer 55. So 55 add 5 would be 60. I could have also counted around the clock 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55 minutes past. Now I look at my hour. Now it's not going to be 3:55 because it hasn't got to the 3 yet. It hasn't gone past the 3. So because I'm saying it has gone 55 minutes past, it would need to be the hour before, so it would be 2:55, which is the same as 5 minutes to 3. And obviously if I'm turning that into PM, I would add 12 to that, which would be 14:55. Okay, let's have a look at the next one. So it says what fraction is shaded, and you have something that looks like this. So I know a fraction has got a line in the middle, and I've got a number at the top, my numerator, and a number at the bottom, which is my denominator. Now my denominator, the bottom number, tells me how many parts. So if I count how many parts I've got 1, 2, 3, 4, 5 parts. So I'm going to have 5 as my denominator. Now I want to see how many what fraction is shaded. I can see that just this one and this one are shaded, so I can say that 2/5 are shaded. For a bonus point, can you quickly tell me what fraction is not shaded? Well done if you said it was 3/5 isn't shaded, because 2/5 are shaded and 3/5 are not shaded. Now we're looking at the perimeter, and I want to know what the total perimeter is around a triangle. So I'm going to need to work out, so I know I've got 6 centimeters down one side I've got 8 centimetres down another side and 10 centimetres down the last side, and to find the perimeter we need to add all of these together to find my answer. So if I do, I could do my biggest numbers first, so 10 and 8 is 18, plus 6, 18, 19, 20, 21, 22, 23, 24. So my answer is going to be 24 centimetres. Now for number 7, if I'm going to use my conversions, I can see that I want to know how many millimetres are in 7 centimetres. So if I look to get from centimetres to millimetres, if I look at my conversions, I'm going to, centimetres to millimetres, I'm going to times by 10. So 7 times by 10, your answer is going to be 70 millimetres, because we're timesing by 10. Finally, what is 28 divided by 4? You could have either drawn, count up in your 4s, 4, 8, 12, 16, 20, 24, 28, and counted how many lots there were. 1, 2, 3, 4, 5, 6, 7. Or alternatively, you could have drawn your 4 circles and shared out 28, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and notice that there are 7 in each circle. Okay, this time, can you tell me the time on the clock and then tell me on a digital clock as well as AM and PM in the morning and afternoon? Then how many fifths make one whole? So if you need to draw a bar model to show how many fifths make a whole, please do that. Then number 10, finding the perimeter. So if it's a rectangle, you're going to first of all need to know what the other sides are going to be worth to then work out the whole perimeter. Then how many meters are equal to 400 centimeters? So think about your conversions. And finally, how much money is there altogether? So write it down, add it all up and tell me how much altogether. Once you've done that, press play and we'll see if you've got it correct. Okay, so let's have a look. So my minute hand is pointing to my 6 because that is my longest hand. Now I know when my minute hand gets to my 6 that it is going to be half past because my hand has gone halfway around the clock from the 12 to the 6. Then if I look at my minute hand, it is past the 4 and on its way to the 5, and if you can see it's actually halfway between the 4 and the 5 because it is half past. So I would say it is half past 4. Now when I go and do my digital clock, I can't write the number half past, but I know that in an hour there are 60 minutes, in half an hour there are 30 minutes, so it's going to be 30 minutes past. And then because it's past the 4, it's going to be 04. If I want to turn it into the afternoon, I add 12 to that, which is 16:30. Okay, let's have a look at number 9 then. How many fifths make one whole? So I've made a bar model with fifths. Now if I shade in until I have shaded the whole, I can see that I have to shade 5 fifths. So 5 fifths is equal to one whole. Because my numerator, my top number, and my denominator, my bottom number, are the same. So it means that it equals a whole, because a whole bar of chocolate has been eaten. Okay, let's have a look at number 10. So I want to find the perimeter. Now, if you had just done 12 add 4, that is correct. However, it's not just 12 add 4, because remember, this line here is worth 12 because it's the same as the top line. And this line here is worth 4 centimetres because it's the same as the line parallel to it. So I needed to do 12, add 12, add 4, add 4. So 12 add 12, 10 add 10 is 20, add 2 is 24, add another 4, 28, add another 4, you should have got 32 centimetres as your answer. Okay, number 11. So I want to know how many meters are there in 400 centimetres. So I want to know how many meters. I know how many centimeters I have. If I look at my conversions to get from centimeters to meters, I'm going to divide by 100. I could have used my shuffling where I shuffle them along the columns. However, because it has got 2 zeros on, if I divide by 100, I can take off my 2 zeros to find that your answer is going to be 4 meters. So well done if you got that one correct. And number 12, how much money is there altogether? So if I write out, I've got £10, I have got £1, I have got 20 pence, 10 pence, 20 pence, 1 pence, and 1 pence. So if I add up what I've got first, so I've got 10 add 1, which is £11. I then want to add my pence, so I've got 20, 40, 50, if I'm adding 20 and 20 and 10 is 50, add 1, 51, add another one, 52 pence. So it should have been £11 and 52 pence. Now you could have also wrote 11, your decimal point, 52, and you didn't need the pence sign. Okay, so now I'll let you have a go at doing these ones. So we have obviously got the clock at the top. Please tell me it's a digital clock as well for extra practice. Then number 13, you're looking at the sequence. Look at the pattern if you're unsure. Can you spot something? Number 14, which fraction of the shape is shaded? Now for an extra bonus point, could you tell me what fraction is not shaded? Then you'll tell me how long the pencil is, so looking at trying to look really closely to see. It might be a little bit difficult to see, so I will let a millimetre either side if you can't see it quite accurately. And finally, number 16, what is 8 times 4? So obviously your 8 or your 4 times table. Now once you've had a go at doing that, press play and we'll see if you've got your answers correct. Okay, so let's first of all start by looking at my clock. I can see my minute hand is my longest hand is pointing to the 10. And I obviously know that this is on the 2 side of the clock. And I can see, I now want to know how many minutes to. So if I start from the 12, how many minutes is it till we get to where my arrow hand is? I've got 5 minutes, 10 minutes. So it's 10 minutes to. And then I want to know where my hour hand is. My hour hand is between the 3 and the 4, on its way to the 4, so it's on its way to the 4, so it's 10 to 4. Now remember when we write it as a digital clock, I would not write 10 here because it is not 10 minutes past, and this is where we say how many minutes have passed. But if there's 60 minutes in an hour, if 10 minutes are to the next hour, we know if we do 60, take away 10, we would get the answer 50. So we could always check it and count around the clock, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 50 minutes have passed. Now if it's not yet at the 4, we would say it's in the previous hour, so we would say it is 03. Or if it's in the afternoon, add 12 to 3, which will be 15:50. Okay, let's continue the sequence then. So we can see that each of them have got the same denominator of 10. So I know obviously my next number is going to have a denominator of 10. I can then look at my top, my numerator, 5, 6, 7. So obviously my next one will be 8. If you carried that on, your next one will be 9 tenths. And your next one after 9 tenths will be 10 tenths. But remember, 10 tenths, the numerator and the denominator are a whole. So 10 tenths is the same as 1 whole. Okay, so this one we're looking at what fraction is shaded. Well, I can count the parts. 1, 2, 3, 4, 5, 6, 7, 7 parts. So I've just drawn that slightly wrong. There were 7 parts, so my denominator will be 7. I can see that the ones that are shaded are the 3rd one along and the 5th one along. I can see therefore there's only 2 parts that are shaded, so 2/7 is shaded. If you were to tell me how many parts were not shaded, you should have had 5/7, which are not shaded. And remember, the reason why that is because you can either count it, or I know that if 2 parts out of 7 are not shaded, I know the difference is going to be 5/7 to get to the whole. Okay, number 15, we want to know how long is the pencil. Now, if I look to see where the pencil starts at 5 centimeters, and it goes up to, now, this is where you need to be really careful and have a look really closely, 9 centimeters. and if we then count how many millimetres, it's gone past the 5 millimetre point, and it looks like it could be 7 millimetres. Now if you have said 8 millimetres, I will also give you that because it is quite difficult to see off the picture. So I want to know, what is the difference? Well, how do I get from 4 to 9? I know that is 5 centimetres plus your extra 7, so 7 millimetres is your answer. However, obviously if you said it was 8 millimetres, your answer would be 8 millimetres. Finally, 8 times 4, this should have been a nice easy one. You could have done your 8 times tables, 8, 16, 24, 32, so your answer will be 32. Or you could have done your 4s 8 times to get to 32 as well. Okay, moving on to our next lot of questions. Can you tell me the time on the analogue clock? Then tell me as on a digital clock and what it is for morning and afternoon. Then you're going to write me 3/10 as a decimal. Now I will just give you a quick reminder. Remember, when we are writing as decimals, write your hundreds, tens, ones, your decimal point and your tenths and hundreds column. Now if it is, say, 5/10, think about if it's 5/10, which column is it going to go into? Well, it's going to go into my tenths column, so I would put my 5 in my tenths column, but because of my decimal point that runs down here, I would obviously need to put my decimal point in, and I cannot leave it as blank before the decimal point, so I'd have to put a 0.5. So think about that when you go to obviously do your decimal, to change that 3/10 into a decimal. Then you're then writing, telling me what fraction is equal to 1 whole. So think about the rule that we spoke about. Think about what else would happen if you need to draw it as a bar model to see, is it a whole that is shaded? Then you can see obviously that clearly. Number 19, how many centimetres are equal to 8 metres? So think about your conversions. And then finally, what is 40? Divide 48 by 2. There's obviously different ways that you can do that. We can do our divisioning, our partitioning, we could count up in our 2s to find the answer really nice and quickly. So I'd like you to have a go at this, press play, press pause, and then as soon as you've had a go, press play and we'll see if you've got your answers correct. So let's start with our analogue clock. So our analogue clock, if I look at my minute hand, it is pointing to the 3. Now again, we know this is on the past side of the clock, and I know that that is 15 minutes past, because if I count down, it's 15 minutes past. However, remember when my minute hand is at the 3, it is a quarter around the clock, so we would say it is quarter past. Then if I look where my hour hand is, it has just gone slightly past the 8, so it will be quarter past 8. Now if I was to write this as a digital clock, remember quarter past, I won't write quarter past, but I will write 5, 10, 15 minutes past. If it's past 8 in the morning, we put a 0 first, and if it's past 8 in the afternoon, evening, we add 12 to 8, which is 20 to 15. Okay, so let's have a look at our next question. Okay, my next question says, write 3/10 as a decimal. Now, because it is tenths and not tens, it wouldn't go in my tens column, it would go in my tenths column. So tenths column, and my numerator is 3, so my 3 would go into my tenths column. As it is next to the decimal point, I would put my decimal point in, and I would put in my ones column a 0, because I cannot have a blank column, so 3/10 is the equivalent, or is the same as 0.3. Okay, number 18, we want to know which fraction is equal to a whole. So if you had drawn out your bar models, you should have drawn out 3, which looks something like this. So if I shade 3/5, is that equal to a whole? Well, no, it's not, because it's not fully shaded. Let's have a look at 9/9 then. So I've drawn 9 parts. If I shade 9/9, so 9 parts, if I shade that, we can see that 9/9 is equal to 1 whole, because it has got the same numerator and the same denominator. Okay, let's have a look at 10/3. Now 10/3, even though the denominator is, the numerator is 10, because my numerator is 3, because my denominator is 3, my bottom number, it tells me the number of parts. But I've now got 10 parts shaded. So I've got 1, 2, 3. Now in order to carry this on all the way up to 10, I've got to do another lot of 3. Because remember, my bottom number is 3, so that's my number of parts. So 4, 5, 6. Need to draw another lot of 3. 7, 8, 9. And another lot of 3. But this time I only want to shade 10. So we can see that is my fraction equal to 1 whole? Well, no, it's not, because if we actually look, it's equal to 1, 2, 3 wholes. But then I've got 1/3 left over. So we've got 3 wholes and 1/3. So obviously that one's not the same, it's not equal to. And finally, 6/7. If I then shade 6 parts, 2, 3, 4, 5, 6, well, we can see it's not equal to a whole because my top number 6 is not the same as the bottom number 7. Okay, so it says, well, how many centimetres are there in 8 metres? Now we know that in 1 metre there are 100 centimetres. Actually, I'm going to turn that round. Sorry, 1 metre equals 100 centimetres. So in order to get from 1 metre to 100 centimetres, we times by 100. So if I times 8 by 100, your answer should be 800 centimetres, because in 1 metre there are 100, so in 8 metres there are 800. And finally, 48 divided by 2. Now you could have done 2 circles and shared it out 48 times, but that would have taken a long time to do. You could have also counted up in your 2s, but we could also see that the number 2 actually goes into 8 and it goes into 4 without any exchanging. So I could have actually done how many 2's go into 8, which is 4, how many 2's go into 4, which is 2, so my answer is 24. Alternatively, you could have exchanged it, partitioned it. You could have done 20 on one side because we're dividing by 2, so we want to make it 10 times bigger. 28 is left over, and if you then divided both of these by 2, I know that if I count up in my 2's, I can know that there is 10 and 14, and if I add those 2 numbers together, my answer would be 24. So it didn't matter which way you chose to do it, your answer is 24. Okay, so this time, can you tell me the time on the analog clock? Then can you tell me as a digital clock as well as AM and PM in the morning and afternoon? Then number 21, you're writing the fraction of what is the arrow pointing to. So think about how many parts you can see there. Then what fraction is 1/10 more than 10/10? So think about how you would show that. Think about maybe writing it as a number line. Then finding the perimeter of a square. Remember, squares all have the same size lengths on each side. And finally, you're subtracting £1.40 from £5. So thinking about how you're going to show that as well. Once you have had a go at doing all of that, you can press play and we'll see if you've got all your answers correct. Okay, so if we look at my minute hand is my longest hand, which is pointing to the 8. And I know this is on the 2 side of the clock. So I want to know how many minutes to the hour it is. So instead of counting from the 8 up, we could start from the 12 and count, and because it's on the 8 and on a whole number, we can count in 5 because I know there's 5 minutes between each number. 5, 10, 15, 20. So now I know it is 20 minutes to, and if my hour hand is between my 5 and my 6, it's trying to get to the 6, so we would say it's 20 minutes to 6. Now if we were writing it as a digital clock, remember when we do our minutes, that's how many minutes passed. However, I know how many minutes to, so I could take 20 off 60 because I know that there are 60 minutes in an hour, and then I would get the answer 40 minutes has passed. You could have, however, counted round 5, 10, 15, 20, 25, 30, 35, 40 to also find your answer of 40 minutes past. Now it's not yet at the 6 yet, so I could say that it has gone past the 5, and if it's in the morning I would put a 0 before it. If it is in the afternoon, remember I need to add 12 to 5, which will be 17:40. So well done if you got that one correct. Okay, so this time, this was a tricky one. So I wanted to know what fraction was the arrow pointing to. Now I know a fraction is a part of a number, and not a whole number, it's a part. So I first of all need to see how many parts I have got. Well, if I have a look, I've got 1 part, 2 parts, 3 parts, 4 parts, 5 parts. I could have also turned it so it looked like a bar model to show where my parts are, and I can see now I've got 1, 2, 3, 4, 5 parts. So my denominator is going to be 5 because I've got 5 parts. Now I want to see how many is the arrow worth. My arrow is here, so I want to know how many parts. So I've got 1 part, 2 parts, 3 parts, so it's 3/5. So well done if you got 3/5 correct, and if you haven't, you should now be able to see you could have turned it into a bar model or seen each of the bars, each of the parts to really show you're working out. Then it says what is 1/10 more than 10/10. So if I do 10/10 and I want 1/10 more, I'm still going to have the same denominator. However, this time I want 1/10 more, so it would be 11/10. However, 11/10 is correct, but you could have also wrote it another way. Now, if I was to draw what 11/10 would look like, I obviously need 10 parts. So I would draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got my 10 parts because remember my denominator is my 10. Now I want to shade in 11 parts. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, because I want to shade another part, I'm going to need to draw another bar model, still with 10 parts because that's my numerator. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, I want to shade 1 more tenth, so I'm going to shade that. So now I can see I've got 11 tenths, I've got 10 tenths plus 1 more tenth, I've got 11 tenths. So now we can see that actually I've got 1 whole bar, because 1 whole bar is shaded, and I have got 1/10 left over because I've got 1/10 here shaded and 10 tenths here shaded. So I've got 1 whole and 1/10. If you were to shade another tenth, I obviously would then have either 12 tenths, or we could say I've got 1 whole shaded and 2 tenths. If you can carry on that pattern to see what your next number would be, that would be fantastic. Okay, the next one was saying you wanted to find the perimeter of the square. Now the square, we knew that one side was worth 5 centimetres. Now we know that a square, every single side is going to be the same length. So each side is going to be worth 5 centimetres. So you could have done 5, add 5, add 5, add 5, or we know there are 4 sides, each is worth 5, so we could have done 4 lots of 5 to find that your answer was 20 centimetres. Well done if you got that one correct. Now for number 24, it says subtract £1.40 from £5. So I need to put my biggest number first, £5, take away, because subtract just means take away, £1.40. Now there are a few different ways you could have done this. You could have converted them all into pence. So I know in £1 there is 100 pence, so in £1.40 there's going to be 140 pence. And so if I know there's 100 pence in £1, in £5 I know there's going to be 500 pence. So that's one way, and you could have used your column method. However, I think this way would be a quicker method. You could have put £1 and 40 pence hit one side. You could have said you were wanting to get to £5, so if I draw my number line, I'm going to go to my next, because I'm already at my 10 with 40 pence, I'm going to go to my next pound, which is going to be £2. And I know in order to get, there are 100 pence in a pound, so if I do 40, and I'm going to add 60 pence, because it's my number bonds to 100, to get to £2, I could then do £2 up to £5, I'm going to add £3, and if I add these two numbers together, you should have said that there will be £3 and 60 pence remaining. Or you could have put £3, put your decimal point in, 60. But remember, we don't need the pence sign, as with the decimal point we already know it's pence. Again, I'll let you have a go at doing these ones. Tell me the time on the analog clock, then tell me as a digital clock for morning and afternoon. Then you're finding 2/5 of the number of lemons. Well, first of all, you're going to need to tell me how many lemons there are in total, and then I want to know what 2/5 are. Now, remembering how we do that, I will show you an example now to refresh your memory. So let's have a look at this example first. Very similar idea, however, I've used different numbers and different objects. So remember, if we're trying to find 2/4 of the number of balls, the first thing we need to do is we need to say how many balls there are. So there's 1, 2, 3, 4, 5, 6, 7, 8. So I want to find 2/4 of 8. Now, in order to do this, so I can now get rid of my number of balls because I've obviously know that it's 2, there are 8, there were 8 in total. Now, remember when we see this sign, a fraction, we are going to divide. I'm going to look at my denominator to tell me how many parts, so I'm going to have 4 parts, and I know my total number is going to be 8. So I'm going to do 8 divided by 4, which I could have either done 4 circles and shared it out 8 times to find that there are 2 in each. However, your answer would not be 2 because if we look at my numerator, it says I want 2 parts. So if I now look, I want 1 part and I want 2 parts. I can see that 1 part is worth 2. So 1 part is worth 2. So 2 parts are going to be worth 4. So please draw your circles to help you to find out, especially when there's more than 1 part that you're looking for. So I'd like you to have a go at doing number 25, then writing 0.3 as a fraction. So I would actually write that on your table first of all, on your column method, and see which column it is in. Then can you tell me, draw a line that is 65 millimeters long. If you cannot draw this, can you actually tell me how long that is in centimeters? And number 28, what is 7 worth in the number 375? And can you, to get some bonus points, tell me what the 3 is worth and the 5 is worth? So once you've had a go doing all of that, press play and we'll see if you've got the answers correct. Okay, so let's have a look at the clock. We know the minute hand is pointing to the 9, so that we know that that is on the 2 side. Now, when it is on the 9, we know that that is going to be 1/4 because it's gone. If we split our clock into quarters, we can see it's on the 1/4 part, so it's 1/4. And then if I look at my hour, it is on its way to the 12, so I would say it is 1/4. Now, when we write it as a digital clock, remember we say how many minutes it's gone past, not how many minutes to. Well, I know from to get from the 9 to the 12, I know it's 5, 10, 15 minutes to. So if I take that off 60, or I count round the other way, 5, 10, 15, 20, 25, 30, 35, 40, 45, I know it is 45 minutes past the previous hour. Then I look at my hour hand. My hour hand has gone past the 11, but not quite at the 12 yet. So it would be 11:45 because it's gone 45 minutes past 11. And again, if we're working it into 24 hours into the afternoon, evening, I would add 12 to my 11, which will be 23:45. Okay, this time we want to know what 2/5 of the lemons are. Now you should have counted the lemons up, and the lemons, there were 2 down and there were 5 across the top, so we could have done an array. 2 times 5 is 10, so I want to know what 2/5 of 10 is, because that's the number of lemons. Now in order to work it out, I'm going to do 10 divided by 5 because that's how many parts. So I'm going to do 5 circles, and I could have either done 10 divided by 5, I know is 2, so each part would be worth 2, or you could have shared them out. Now, but then we need to look at my numerator. Now my numerator says it wants 2 parts, so I want to see what 2 parts are worth, and if I find what 2 parts are worth, I know 2 parts are going to be worth 4. So 4 is your answer. You could have got some extra bonus points if you said 1 part, 1/5 was worth 2, 2/5 were worth 4, 3/5 were worth 6, 4/5 are worth 8, and 5/5, which is the whole, are worth 10. Okay, this time we're going to write 0.3 as a fraction. So I'm going to do my hundreds, tens, ones, and tenths column. And I'm going to just quickly draw mine, and obviously my decimal point goes between my ones and my tenths. Now if it's 0.3, my 0 obviously goes in my ones column, my decimal point, and my 3. Now if I look to see where my 3 is, I can see my 3 is in my tenths column, so I know my denominator is going to be 10, and I know the 3 is in my tenths column, so 0.3 is the same as 3/10. Then for you should have drawn a line that was 65 millimeters long, or if you couldn't do that, you should have said that to get from millimeters to centimeters, we're going to divide by 10. Now, if you had done your place value columns and wrote in 65, remember, if we're dividing by 10, there's 1 0, so it moves 1 0, one place to the right because it's getting smaller because we're dividing. So if I move all my numbers one place to the right, I also need to put in my decimal point. I should have said that there was 6.5 centimeters in 6 meters at 65 millimeters because there's 6 whole ones and 5 millimeters left. Finally, in 375, if you had partitioned them, you had 300, you had 70, and then you had 5. So well done if you got those correct. Finally, the last few questions. So tell me the time on the analog clock. Tell me it's digital as well. Then for 29, you're finding a third of the number of oranges. So again, counting the number of oranges that there are and finding a third of it. Then for number 30, you're writing 7/10 as a decimal, so please make sure you use your column method to write it in to see where it's going to be. Then you're adding 3 meters and 20 centimeters to 2 meters and 55 centimeters. There's obviously the different methods we've covered. And then find the sum, the total of 462 and 229. So that's a nice easy one to finish on. Once you've done that, press play. We'll see if we've got them right. So if we have a look, my minutes hand is pointing to the 4, which I know is past. I count how many minutes past, 5, 10, 15, 20, which is 20 minutes past. If I look where my hour hand is, it's past the 6, so it's 20 minutes past 6. If I was to write it as a digital clock, remember it's 20 minutes past, so I can put that on my right hand side. And if it's past 6, it's going to be 6, and obviously put a 0 before if it's in the morning, and if it's in the afternoon we add 12, which is going to be 18:20. Okay, for number 29, we wanted to know what the 1/3 of the number of oranges was. So we first of all count the oranges. There are 2 down and 6 across, so 2 times 6 is 12. Now I'm dividing by 3, so I'm going to do 12, which is my whole number, divided by the number of parts, 3. If I draw my 3 parts, 12 divided by 3 is 4, or you could have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Obviously there are 4 in each part, and if I look at my numerator, I only want to know what 1 part is worth, so 1 part is worth 4 oranges. Number 30, we are writing 7/10 as a decimal, so I need to first of all draw my columns, put my decimal point in. If I have 7/10, my 7 is going to go in my tenths column. So if I write in my 7, I obviously need to put my decimal point, and I can't leave anything in my ones column, so I must put a 0, so it's 0.7. Number 31, I'm adding 2 measurements together. Because I'm adding them, you could have done, and there's not looking like there's going to be any converting, I could have added my meters first. So 3 meters add 2 meters is 5 meters, 20 centimeters add 55 centimeters. Well, I've got 0 ones and 5 ones is 5, 2 tens and 5 tens is 7, so 5 meters and 75 centimeters. And finally, number 32, you should have worked out using column method. I started my ones, 2 add 9 is 11, but I can't remember I can't put 2 in one column, so I exchange. 6 add 2 is 8, add 1 is 9, and 4 add 2 is 6, so your answer is 691. Once you have had a go at completing all of those, please do put them on Seesaw so I can have a look at